The first chapter will be momentum. Newton's first law tells it that objects remain in motion with a constant velocity, unless acted upon by an external force. Another name for this is the law of inertia. Now, in our experience, if you have objects of different mass, but they're moving with the same velocity, which one is harder to stop? Clearly the one that is more massive. However, if I have objects of equal mass and they travel with different velocities, again, sort of an intuition, and also you've probably seen this, the faster one is harder to stop. If someone's throwing you a baseball and they throw it very slowly, pretty easy to stop. They throw it at 90 miles an hour, you need a great force to stop that thing with your mitt, and you will feel it. Our observation as to how hard it is to stop an object takes into two factors. The mass of the object, bigger the mass, the harder it is to stop. The velocity of an object, the faster an object moves, the harder it is to stop. So we're going to define a new quantity called momentum, and the symbol for momentum is P. Actually, not sure where that came from, but we really can't use M because that is mass, so we just use P for momentum. And we are going to define momentum as mass times velocity. Now, what's wrong with the way this is written? What's wrong with this equation is the way it was written. This right here is the proper way to write the equation. Why? Mass is a scalar quantity. That means it has no direction. Velocity, however, is a vector. It has magnitude and direction. And there's a math theorem that shows that the product of a scalar and a vector is a vector. It may not be a theorem, maybe it's a definition, but that's okay. If you have a vector multiplied by a scalar, which is a pure number, you get another vector. So since momentum is mass times velocity, it also is a vector quantity just like velocity. So we will write it with an arrow over its head. See, there's the P with the arrow. There's velocity with an arrow. Momentum is mv, where momentum and velocity are both vectors. Unlike other derived quantities, where the quantity is the product of two or three others, and you take those units and then you combine it, you come up with a new name for it, we don't have that for momentum. There is no specially named unit for momentum. So frankly, there's a nice opportunity for it to be renamed now after a renowned physicist, perhaps. So all we're going to use are the units of mass and velocity. So kilogram meters per second is momentum. Whenever we talk about momentum, we have to specify a direction. Is it to the right, up, down, to the east, or frankly any description you want, as long as it's understandable and whoever you're working with agrees with your criteria.